Hello everyone, welcome back to my channel and it's me Akil KK. Today we are starting a new series to build a self-driving car with CARLA simulator and ROS2 Humble. Our goal is to develop a software stack to drive a car autonomously in the simulator. In this episode, we'll achieve the basic objective of a self-driving car, nothing but making the car to drive autonomously from one point to another in the CARLA map. In this episode, we will cover how to run CARLA simulator, how to spawn vehicle in the simulator with ROS2 bridge, and how to visualize CARLA roadmap and ROS2, how to select destination point in ROS2, and use ROS2 waypoint publisher for finding route from starting point to the destination point, and use ROS2 local planner to drive the car to follow the route which is obtained in the previous step. Now let's dive into the project. First, open self-driving car CARLA ROS2 repository. You can find the repo link in the description. Directly open from there. The steps are explained in the README document. Here, aim of the project is already explained. Now let's see the software requirement. Basically, we need a PC with Ubuntu 22.04 OS version, and then ROS2 Humble and CARLA 09.15 simulator, and CARLA ROS2 Humble bridge, and Python 3.10.12 version. Now, what is a self-driving car? In simple words, a car which can drive itself without human input. As simple as that. What we need to build a self-driving car? Basically, we need a vehicle and required sensors attached to the vehicle, a master processing unit, and actuators to control the vehicle based on the controller, a world to test the vehicle with different road conditions and scenarios. Since creating a test vehicle with all above requirements is very expensive and testing in real world is challenging task, the best approach is to use a simulator. Here we are using a CARLA simulator, a bit heavy simulator with rich features. Please visit CARLA official page to get to know more about the simulator. Now let's come back to the page and start preparing the environment and packages. First, install ROS2 Humble. For this, open official page of ROS2 Humble and follow the steps mentioned there. The link is already provided in the description. You can just follow that. For installing CARLA simulator, the first step is to create folder structure for the whole project. Open a terminal and follow the commands mentioned in step 3. After creating the folders, you can use the commands mentioned here to download CARLA simulator binary, or you can directly download it from GitHub release page and extract it under CARLA project folder. Since I already have the zip downloaded, I'm not going to download it again. Instead, I'm taking the zip file and directly extracting it under CARLA project folder. Next, go for CARLA ROS2 bridge installation. Please refer CARLA ROS2 bridge repository for details. The link is available in the description, or it's also available in the README doc page. Open a new terminal and follow the commands mentioned here to clone the repository and build the package. And also, please note that if you have Anaconda installed, then please deactivate it by executing contact deactivate command before building the package. The reason is some package of Conda have conflict with ROS2, which can lead to a build break, especially with graphics and GUI. Once you finish building ROS2 CARLA bridge package, then it is time to clone self-driving car CARLA ROS2 repository. Open a new terminal and follow the commands to clone this repository and build the package. The package will be cloned under CARLA _ROS2_WS folder. Basically, this repo contains the package named navigation HMI, and it is responsible for CARLA road network visualization and destination selection and initiating the drive. After building this package, we are ready to run phase 1 demo. In phase 1, we will implement basic objective of a self-driving car. That is, drive a car from starting point to a destination point. Here we are not bothering about collisions, traffic rules or complex maneuvers. First, open a terminal and run CARLA server with the given command. Now you can see a window popping up. This is CARLA world where all your vehicles objects are created and being tested. Keep this window open and also don't close this terminal until we complete our demo. So basically the CARLA server should be running so that all your different nodes will communicate with it and we can achieve the final test. Next, we need to spawn a vehicle. Now open a new terminal and then as like we did before, deactivate conda environment and then source ROS2 package, then source CARLA ROS2 bridge package and then set CARLA root environment variable and then CARLA Python API path in Python path environment variable. Then spawn a vehicle with the given command. Now you can see a Pygame window appearing with a vehicle in it. So you successfully spawn a vehicle in the CARLA simulator. By default, the car is configured to controlled via ROS2 topics, or we can say that it is in auto mode. But if you want to drive it manually, then first switch to manual mode by pressing B key in the keyboard. Then you can use arrow keys to drive the car. Once you test the car, then switch the car back to auto mode by pressing B key again. Note that the car won't be controlled by the software if it is in manual mode. And also keep this window open, which means the vehicle should be running throughout our phase 1 demo. We spawn a vehicle already. Now we need to initiate a route planner. For this, launch CARLA ROS2 waypoint publisher. This node is responsible for creating a route from one point to another in CARLA map. Okay, open a new terminal and execute the commands to launch the waypoint publisher. Also don't forget to deactivate conda in the beginning itself. The waypoint publisher waits for a goalpost topic to create the route. Basically, goalpost is nothing but a destination point in the CARLA map. So once it receives the goalpost, the waypoint publisher publishes a route to CARLA/waypoints topic as a list of waypoints. Okay, so now the node is running, and keep this terminal open so that the waypoint publisher will be waiting for the goalpost. Our vehicle and the route planner both are ready right now and they are running too. Now run a controller node to drive the car to follow the route published by the waypoint publisher. So this node also expects a speed command from the navigation HMI. Okay, and now open a terminal and deactivate conda environment in the beginning and execute the commands to run local planner node, or basically the controller. Once it is initiated, the local planner waits for the input from waypoint publisher for the route and wait for navigation HMI node for speed command. So once the node is running, keep the terminal open and we will initiate the next node. Next, we will run navigation HMI node. Open a new terminal and execute the commands to run navigation HMI node. This node is responsible for publishing CARLA road network as marker array to visualize in ROS2, and also it reads the destination point selected by the user in ROS2. Once the user selects a destination point, this node will publish a goalpost info to waypoint publisher and also a speed command to local planner node. The speed command is nothing but the speed to be maintained by the vehicle during the drive. We will keep it as 20 km/h for now. Once the node is running, keep the terminal open and we will go to the next step. Next, open ROS2 to visualize all operations together. Open a new terminal, deactivate the counter, source ROS2 first, and then launch ROS2. To visualize CARLA road network published by Navigation HMI, add a new marker array display type and choose topic as CARLA_road_network. After selecting the topic, you can see the road network in ROS2. To visualize the vehicle in this map, add another marker array display type and choose the topic as CARLA/markers. Now you can see a green box in the road network that represents the position of our vehicle in the CARLA map. Add another path display type to visualize a route published by Waypoint Publisher and select the topic as CARLA/hero/waypoints. And to see this route from the CARLA road network, please select the color as red. Next, add an image display type to show the camera view of the car and select topic as CARLA/hero/RGB view. Now you can see the camera image of the car in the side panel. Now we are all set to start our demo. Before running, let's have a look into the architecture graph to understand the nodes and topic involved and their communications. Open architecture graph from a new terminal. Here the starting point is CARLA Navigation HMI node. Basically this node publishes CARLA roadmap to CARLA road network topic and it will be visualized in ROS2. When users select a goal post in ROS2, this will be published to goal_post topic and this will be subscribed by CARLA_navigation_HMI node. After receiving goal post, the navigation HMI node publish goal post to CARLA/hero/goalpost topic. Along with that, it will also send speed command to the CARLA/hero/speed command topic. The topic CARLA/hero/goalpost will be used by Waypoint Publisher to calculate the route and it publish the route to CARLA/hero/waypoints topic. The published waypoints will be used by local planner node. Along with that, the speed command received from navigation HMI node to publish commands to drive the vehicle via ROS2 CARLA bridge. That's the overall working from ROS2 point of view. Now let's start running the demo. First open ROS2. Here you can see the vehicle and CARLA road network. Now click on the 2D goalpost option and then click any destination point in the CARLA road network. Once you click on the destination point, you can see a new route visualized in red color, which is created by the Waypoint Publisher. At the same time, you can see that the car start following the route. You can observe the car movement from the Pygame window, where you can see different vehicle parameters as well. The car will continue following the route and stop at the destination point after some time. So maybe let's have a look how it performs. You can choose another destination point in the map to make the car drive again. Also, you can observe how the routes are planned by the Waypoint Publisher and observe the performance of the controller. you can play around with a different destination point with the same setup. Finally, we successfully completed phase 1 goal. Here the car is not following any traffic rules, and it's not even bothering about any collisions. That we will handle it in upcoming videos. And that's all for today. Thanks for watching, and see you on next video. Bye.